Today we present about our project is Battleship. We have to talk about seven sections. What is Battleship? Our project help to play demo structure games, reminder map, data structure and algorithms. So what is Battleship? Battleship is a popular board game in the world. To play this game, player needs to place the ship on the board, then guess the positions of enemy opponent's ship. The player's mission is to destroy all the opponent's ships without knowing their locations. In our project, Virtualized 2 in 1, we have a map that describes both player and enemy territories, increase the efficiency of your control and decisions. We have a novel ship design that breaks with traditional heuristics, increasing excitement of player while playing this game. Automatic playing machines. Cause the new design ship shoot prediction will no longer be the same as traditional predictions. We investigate an algorithms that present a challenge to player. As a result, player will have another worthy how to play. For moving, just use an arrow key for move and Q button to select. About the missions, you have to fill the map with night shift. In prediction mode, use an arrow key and Q to move and shoot. The winner is the first one found all enemies ship below the map. So here is our games. First, we will see this annotation. This is instruction for this game, then how to play it. Here you have to fill the ship on the board by using Q to select and arrow key to move the object. Actually, you can use E button to delete what you were selected. So here you can see that deleted and you can rechange it. So I will delete it again for you to see that here in deleting mode. So you just press E and press Q so you delete the shape at this point. The shape here and go here. Structure of games. In the left, in the right is the overall map for this game. We build it by using HTML and many logics 5GS to interact with canvas. The most important logic game is the game loop. In this loop, first conditional is checking. Does player fill all matches into map or not? If not, draw canvas, which can allow moving object in the left map. If conditional is true, still drawing canvas and check did we found a winner? If its answer is yes, show dialog to notificate for player. Else, check whose turn to shoot. True value for the enemy shoot, and false value for player shoot. Here's a more detail about draw canvas method. We have to do four steps. Clear context, draw map layer, draw static object, draw moving object, instruct static object. In this layer, we are mapping the positions on the map with a reminder map. We use a little bit math in this to flag and perform the static object followed. In reminder map, draw moving objects. This for draw all object that user can control on the surface by update direction signals, updates position of object in object values, and draw object. Reminder map. We use total for reminder map with a separate meaning to serve shape data storage. Enemies, enemy checker, player, and player checker. About player, this reminder map used to store position a player ship, so we can access and perform this on the static object layer. The enemy, this reminder map used to store positions of enemy ship. Basically, we create a function to allow us to generate new map for enemies every time user reload the game. Player checker. We perform state a ship on map with this reminder map. With the value 10 for hit and minus 10 to miss the ship. You can see here. Enemy will use this map to make assumption about the show. Enemy checker. We perform state of ship on map with this reminder map with values used the same as player checker. And player will use this enemy checker to make assumption about the shoot. Does it hit or misses? We can see that the image of ship and reminder map is mapping together, like here, and it's true with all four reminder map. Data structure and algorithms. So in this part, we have done 80% of these presentations. Relevant. Next is about data structure. We use array to create a reminder map for player and enemies. Q to control type number of ship. Stack using in enemy shooting selection algorithms. Additionally, use declare attributes of object. We move to the algorithms. For this project, we have to build an automatic playing machine. In addition, this project also have another difficulty related to game loops. In this session, we will discuss method for solving a both problem. Problem 1 is file and draw object in map. Problem 2, automatic playing machine to shoot the ship. In this game, method to perform ship is convert from reminder map to draw on the canvas. You can see here. So we check the reminder map if this point is larger 0, update the value in square with size equal value of this point to avoid draw duplicate image on the previous image. Then the result we expect is in the left picture, but in real life the result is in the right. What happened to algorithms? Is it wrong? So we have appendix A here, game loop. The game loop is run repeatedly in game programming. An example for this term is APS, which is used frequently. This explains why our algorithms not work because it changed the initial value for the next access, so we can have the same result each time we call back the loop. To solve it, we need to update the initial value for like a complement with a after completing the work. Here's how we can implement into the code. We convert the array set after processing. For the map, we update again to return the initial value for the array. So our algorithm will work. Next is appendix P, shooting point. Here is the material this game using, like reminder map and canvas. We note the value of shift into reminder map for set later. Here, you can see is a note in the reminder map and draw it on the canvas. Here I'm talking about intersection point. You can see here is for shift as on the has one point that shows just only one point. It can be a part of this for shift. So here is presented on the map. Here is one point for this for shift around it. Applied to our map, we can see here is a 5x5 board. We just need to check 4 points to identify does any ship appear on this board or not. This long method is prepared for you to understand what I do in next slide. At this point here, a blue point, I can move to three more directions from the initial point, and and from the next point I can move to another point, which not be blocked by the red part. So from one point I can visit all the places are not blocked by the orange color and this file is fly 5 bar. So main method for our automatic machines is here. We put all interaction point into the stock. Pick the top explain with load with like ideas compare with reminder map, repeat until the empty stock. Here is the main algorithm of us. Here explain why. So we move to the example. First we pick the top of point. Then we check. Does this file a ship in this point? So here is none. So we pop it out. Move to the state 2. We pick the point 3 and 7. We check it. We found the ship in here. We pop it out. Then use the line ideas to push the left, right, and down part. Left, right, and right point of this point. Continue. We pick the 3, 8 out. We check. We found here is the ship, so we pop it out. Then we use the line idea to push the left, the right complement, and down complement. Next to the state 4. On the top, we pick out the down complement, which value is 3 in 9. We check, we not found the ship, then we pop. So we will continue with another point until this stack is empty. So we can find all the ship can be in this map. And this is the main method for our automatic code playing machine. Here is the coding. That's it. Here is me, and thanks for watching our presentation about Battleship Project. Thank you.